Okay. So it is time for us to start. Today, I'm just going to go a little bit over an overview of Arduino and a little bit about coding for Arduino and a little bit about hardware. Right. So like I said, we're doing introduction to Arduino. So why do we use Arduinos? One of the main reasons, or these are most of the main reasons. They're inexpensive, very cheap microcontrollers, right? And you can also do cross-platform developments. What we mean by that is the Arduino, you can code it using Mac OS, Windows, Linux. There's pretty much any platform that you have, you will be able to code for the Arduino and upload that program into its memory. The other thing is that it is very simple to use and learn. You don't need to know programming very well from the beginning in order to learn how to program Arduinos. You can use Arduino as one of the first things that you're learning in terms of programming. It is also open source with a lot of available pre-made software for the Arduinos. So you can look up projects and you can look at their code, download it, upload it to your Arduino. And you can also use these projects as a starting point. If a piece of it maybe matches what you want to do for your project. The other thing is the hardware is also open source. So going along with those open source projects, they usually also include diagrams on how to connect those things or the sensors and everything to the Arduino in order to make it work. But also the Arduino hardware itself is open source. So anyone that wants to make their own Arduino chip or board, they can go ahead and use the Arduino basis, add any features they want to it, and create a board. And that's also going back to why it's so inexpensive. Because there's lots of board makers that are making these Arduino boards. All right, so this is the Arduino board that we are using. We're using a Mega 2560 and revision 3, so version 3 of this. And the Arduino is very simple. So this chip right here, that's the main processor. This is running ARM, and that's the CPU for the Arduino. So it's running an ARM ISA. And then you have the different interfaces for connecting to the Arduino. So the first one here at the top, that is, switch to Blaze point. This is the USB. This is used to connect the board to the computer in order to upload your program so that the Arduino can run it. You can also use the USB to power the Arduino. It doesn't have to be for only data. This is to power the Arduino if you don't use the USB to power. And then you have a few different outputs as well. So you have a few LEDs to indicate the status. Like this LED is to indicate the power. And then you have a built-in LED that you can use for your program to indicate any kind of status that you want. And then these two LEDs are to indicate the communication between the Arduino. So if you're using the USB port to communicate or the TX-RX ports down here. It's like a hard drive activity LED kind of thing. And then you have these GPIO. So does anyone know what GPIO stands for? So GPIO stands for General Purpose Input Output. So these pins are for our input and outputs. And some pins have multiple different functions, while others have single functions. Like these pins here, you can see that they're labeled as just ground or 3.3 volts or 5 volts. And that's all that they are. They're not for communication. They're not for analog inputs or outputs. They are simply to power the various sensors from the board, whether it requires 3.3 volts or 5 volts. And then you have these other pins. You have down here, if they're labeled as digital pins, they're for digital input or outputs. And then you have analog pins that are for analog input or outputs. But you can see the board that we have has many different, has like 50 pins or something like that in terms of input and output. All right. The other thing that you're going to learn about or use are breadboards. So has anyone worked with breadboards? Okay. So I'll explain this a little bit then. So across here, if they're in the same row, like this, or in this case, it's shown as a column, all of these inputs are connected in series. They're all connected to each other. So if you want to connect something to something else, you connect them into the same row. And then all of the well, let's call them columns now because that's what we're looking at. And then all of the rows, in this case, are separate. So if you didn't want something to connect, you wouldn't put it into the same column here. You put it into a different column. And this just allows us to very quickly put circuits together rather than having to solder or connect them in that way. So it's used for prototyping and also for very small projects like the ones that we will do in this class. So this week we will work with the breadboards and you'll see how to use them for the first project. And the other thing that is usually standard practice for the breadboards are these, you see the plus and the minus. So those are for usually powering your devices. So you'll usually connect ground to the minus, and then from say like the Arduino board, you can grab 3.3 volts if the sensor is requiring 3.3 volts, and you would connect that here. And then all of these pins on this line are all connected to each other. So if you need a sensor that requires power, you just connect the sensor to the power lines here. And then there's also usually 2 of these for breadboards because maybe you have one for 3.3 volts, one for 5 volts. So we're going to use these breadboards quite a bit. Is it clear how things are connected in the breadboard? Okay. So we will work with these this week. And then in terms of connecting things to the breadboard, we're going to use these wires. So have you guys seen these before? Okay. So they're just for connecting. For the most part, we will be using male to male ends. This one is a male to female, just so I could show you both of them. So the female end accepts the male end, right? The breadboard accepts, all of these are female ends in the breadboard. So you connect the male end into here, into the breadboard to make a connection. And then the reason that we're going to be using mostly male to male is that's also on the Arduino side, all of these pins are, for our board, are female. That's not the case for all Arduinos. Most of them actually are male-ended on the board, just because it's cheaper to manufacture that. But for us, it's female on the board, female on the breadboard, and then the sensors are usually male, so you can put the sensors onto the breadboard and then connect them to the Arduino with the male to male jumper wire. That's how we're going to make our connections. There are some sensors that we have that would be a little bit more convenient to connect with the male to the Arduino and then female to the sensor. So we will use both kinds of these jumper wires, but just know that we have this male end, female end, right? And they're just for making connections. And then the color coding is used for convenience, right? You don't need to make things color coded, but having a standard helps when you're looking at a circuit. Usually the standard is that ground is going to be either black or green, power is going to be red, and then all of your data lines, you would give them the different colors so that you would know. But for USB, if you're using TXRX, usually it's brown and blue are used as the color coding for that. But again, you don't have to follow these standards. All of the wires are the same, you're just making a connection, right? But it is helpful to be able to just visually look at your circuit when you put it together with the breadboard and the Arduino, so you know which one is power, which one is data, things like that. So is that all good? Yeah.
For the colors, does it matter which one? Like, say I want to plug like a black one, but like it says I have to plug a blue one in. Will it not work, or it'll just?
They're all the same.
Okay.
It's purely for information purposes. Having a standard of, if it's black, I'm connecting them to ground. But if you wanted to connect a red wire to ground, that would still work. They're all just for making connections. The color is just to help you differentiate them, especially when you get into larger projects. Like for this first project, you're going to need just 2 or 3 wires. It's not, you're actually only going to need 2. Yeah, you only need 2 for the first project. So as long as you use different colors for those 2, it'll be very easy to see it. But if you get into much larger projects where you're going to have hundreds or thousands of these wires, it's a lot more convenient to have a standard. Right. So we've talked about sensors and actuators before, right? So if we have a LED, is it a sensor or an actuator? Yeah, it's an actuator. Why is it an actuator? Because it modifies the environment, right? So it does something to the outside world. In this case, it's just emitting light to the outside world, right? And then we have sensors. So this is a ultrasonic sensor. And it is a sensor because Yep, it just detects changes in the environment and is not capable of making changes to the environment. So for the most part, actuators are outputs of our systems. Sensors are inputs to our systems. And all of these sensors and actuators are going to be powered and connected to the board through the GPIO. Right? The GPIO stands for General Purpose Input Outputs. So inputs from sensors, output to actuators. So we're going to go over a few sensors throughout the course. The first lab, you're just going to learn how to turn an LED on and off. But there are also many different types of LEDs. Like you can have variable brightness LEDs as well. So it's not just on and off. It's how bright is it when it's on, or how dim is it when it's on. So those will have different code and different pin modes in order to drive those actuators. Same thing for sensors. So we'll show you a few and we'll walk through looking at the data sheets and seeing how to connect that to the Arduino. But then once you see how that works, you should be able to look at a data sheet for a sensor or an actuator and know how to connect it to the Arduino and what to do for the coding parts for that sensor actuator. All right, so in Arduino, in terms of the code structure, there are two main functions that you will see as starter code. If you open up any new project, you'll first see void setup. So how familiar are we with C++? Anyone not familiar with C++? It's okay to raise your hand. I just want to know. Okay, so we all know C++? All right. So void, what does void mean? Yeah.
It doesn't return anything.
Yeah, it doesn't return anything. All right, and what goes in between these parentheses? It would be inputs into the function. In this case, we have no inputs. And this function, in terms of on the Arduino, when it starts, it runs this function once. And this is where you would put all of your code to set up any initial values or pin modes that you will need. So when you're connecting things to the Arduino, a lot of these pins can be used as inputs or outputs. You need to specify, is it an input or is it an output? As well as, is it going to be analog or is it digital? Is it going to be pulse width modulus, which is PWM, or is it just high or low in terms of digital? So this is where you're going to set up all of your pins that you're going to use. And then you have another function that also returns nothing called loop. This is the main body of the code. This gets called continually. So it just keeps, it's put in a while loop, essentially. And it will just keep running. So this is where you put the main body of your code. So this is where you would read from sensors, write to actuators. And we'll look at the functions that you would use to set up the pins, as well as to read or write to those sensors and actuators. And the other thing is, these are the only two functions that are given in the starter code when you make a new project, but you can add any helper functions that you want. So this will increase your code quality and readability if you have helper functions. So generally, we don't want our functions to do anything more than one function. So if you only have loop, and you're designing a larger system, it's going to be very hard to read through it if you do everything in that one code block. But if you split it up into its individual functions and then call those functions in loop, it'll be a lot easier to read, especially if you give your functions descriptive names, right? So I do encourage you to add helper functions in order to maintain your code quality and readability, not just for yourself in the future, but also for any partners that you're working with on these labs. And this is a skill that you need to kind of build and maintain throughout your lives, because you're after here, when you go into industry, you're not the only one looking at your code, right? You're going to have code reviews with your project manager. You might even have code reviews with someone that is not technical, but wants to understand what you have worked on, like maybe someone from the management side, right? So if you are able to show them your code and you have all of your functions using meaningful names, it'll be easier in the future to do these code reviews, as well as if you leave a project, someone else is taking over. If you have all this messy code, it's going to take them a long time to figure it out and just even get started, right? But if you maintain your code quality, maintain good practice, when you hand things off to peers, it'll be a lot easier for them, right? I can't stress how important this is. This is one of the key skills that you will learn throughout your coding career. All right, so in terms of data types, there are many different data types in this. These are just the basic ones to start with. So we talked about integers already, right? So these are signed 2's complement values, and they are 32 bits. So you can represent from -2 billion to +2 billion. There's also characters. So these are used to represent a single character, like the character A, B, C, a 0, a 1, things like that. You can also have strings, which themselves in the backend are just arrays of characters, but you don't have to write them as arrays of characters. Just like C++, you can put them in double quotations, and that will make an array of characters as a string. Okay. And then we also have floating points. So we went over floating point precision, the representation, right? So this is used when you have really, really high values or really, really low values, when you need that precision. Any questions on data types? We're all good with this? All right. So in terms of operations, it seems that we all know C++. So the syntax is the same as C++. Coding for Arduino is just kind of a branch of C++. So if you know C++, you will be fine in coding for Arduino. If you wanted to do simple math operations like addition, subtraction, multiplication, division, modulus, and exponent, it's all the same as C++. If you wanted logical operations to do Boolean logic, you can use these as well. So this works for if you wanted to have multiple conditions in an if statement, as well as if you wanted to do logical operations like bitwise AND on some variables. And then you also have these comparison operators. So are things equal? Are they not equal? Greater than, less than, greater than or equal to, less than or equal to. These are comparisons that will return a Boolean object, which you can use for statements and structures like if statements, while loops, things like that, right? So we're all familiar with if statements, case statements, for loops, while loops in C++. So what are you not familiar with?
Okay.
So we will learn them as we go. So I'll make sure that if one of the labs is requiring these, I'll cover them before we do the labs. Okay. All right, so here are the key functions in Arduino. So we have pin mode. It actually takes two inputs here. One is the pin number. The other is the mode of the pin that you're trying to set it to. And it's just going to set the pin as input or output for the most part. This is not the only things that you can set them to, but to start with, this is what we're going to use. So if you connect your sensor to pin 13, so D13 right here, you would then use pin mode, and it's a sensor. So the pin mode would be input, right? And then in terms of the pin number, it would be 13. And going back to this, maintaining code quality and readability, sure, you can put the number 13 into the input of this function, and that would work just fine. But it may be beneficial to make a constant called LED pin or something like that, and make that 13, and then use that as the input into this function. Because you'll also need that pin number in order to do other functions in the loop, which is the main body of your code as well. So it's a lot easier to read your code if you see that pin mode LED pin is being set to outputs, then pin 13 is being set to outputs. Okay. And then especially if you're doing the digital writes, you can see that LED pin is being set to high, meaning the LED is being turned on, right? So again, pin mode is for setting things up, and then digital read, digital write, analog read. These are going to take in two variables as well. The first one is the pin number. The second one is what you're going to read or write, right? So for digital, it's going to be high or low, right? And it's just going to be writing to actuators or reading from sensors, right? And then we have digital components as well as analog components. We're starting with digital components. We will probably look at some analog components throughout the rest of the semester. And the other function that is useful, especially for this first lab, as you're going to use it, is there's a delay function, and it takes in a integer variable that is going to add a delay to the code in milliseconds. So if you wanted to wait for 1 second, you would delay 1,000. Okay. So any questions on these? What they're for? How we're going to use them? What sensors and actuators? All right. So here is your checkpoint for today then. Your code is, what is your code? 584. So do this one on your own first. Okay, guys all standing, changing their answers. Is anyone still thinking about this? All right. So do talk to each other. Talk about why you got to your answer. Resubmit after you guys have discussed.
For outputting. The visual right, because they could do like. So you know, it's in these.
Actuator.
So you did doing different, they, companies. And then. I think they're.
So I'm in the Taylor and GSL, right?
Data using new values.
Oh, Nathan, what is that? Yeah.
It's like, some of the.
So easy, they don't automatically, you just convert their out.
Like, literally, you just kind of like convert it to a. Oh, yeah, that was like from like. I don't need this anymore.
That's like a whole separate bug.
I need it. All the work stuff. Why couldn't we just?
That's the right, not wire ranges. Oh, that's wow. So some is right or something. I was like, bro, there's no way that one is.
Right, like for me, like getting lost and like. Yeah.
I just look up who's strong and look at it.
Did you change your answer if you were convinced to change your answer? All right. So let's just do one part at a time. So it is an LED. So is it a sensor or an actuator? An actuator. So an actuator is input or output. It is outputs, right? So we want to have outputs. So we're left with B, D, and E. And then we have to decide, should it be digital writes, analog read? So if it's outputs, am I reading? No. So I like writing, right? Because it's an output. And the question is digital or should it have been analog? So B or E now, right? So should it be digital or analog? All right, digital. Why?
Either like on or off.
Yeah, it only has two states. It's either on or it's off. Okay. So it's going to be B. It's an output. So we do pin mode, whatever pin we're using, set it to outputs. And then when we want to turn it on or off, we would use digital writes, the pin number, and then high or low. Right? So high would be to turn it on, low would be to turn it off. And we are going to do this in the first lab. So the first lab, you're going to download the software, Arduino IDE. And the very first thing you're going to do is connect an LED with a resistor to the Arduino board and turn it on and off. And it's mostly just to get you started with connecting things to the Arduino board through the breadboard and using these functions in the Arduino code, as well as verifying that your Arduino IDE install is working properly. So we'll go over more about how to get started and hopefully have you guys all install the software on Wednesday. And then you can, if you finish doing the lab on Wednesday, that's good too. But we will have Friday to work on the lab reports or finish the lab. So the goal again is to try and get most of this stuff done in class. Right. So we can end today a little bit early. And if you want Wednesday to maybe go a little bit faster, you can find the lab instructions on Canvas. And you can get started with downloading the software. But in terms of having the Arduino and the LEDs, they're stored here. So you'll have to wait until Wednesday. But if you want to talk to George and start early, you can ask him to check one of the kits out. Okay. So any questions before we end today? All right. So that is all.